Okay, hi mathematicians, I'm back. My computer has a hard time processing videos that are close to 20 minutes, so I have to make sure they're less than that. So, um, if you're just tuning in for the first time, we are proving that the limit of x squared as x approaches 5 equals 25 using the epsilon delta definition of limits. And so the first thing we need to do is define delta. And we always start with this statement here. Absolute value of f of x minus L is less than epsilon. So we're saying that the distance between f of x and this limit L is less than this value epsilon that has been chosen, right, with epsilon greater than 0. And so we went ahead and we plugged in x squared for our f of x, and we plugged in 25 for our L. We factored into x minus 5 and x plus 5 because we love to factor. And that's great because what we're really looking for right now is we're looking for some kind of expression x minus a less than delta, with a is 5 in this situation. So we have our x minus 5. We also have this x plus 5, and we need to do something with the x plus 5. We need to get rid of it, right? We need to turn it into something. It needs to go away. And so over here, this is some side work, right? We're going to make some logical conclusions or logical statements about how far away, about what x can be. That's basically what we're doing, right? Because we're looking at this and we're like, okay, well, what values can you be? X plus 5, who can you be? And we're really interested in the max x plus 5 can be. That's what we're really interested in. Why? Because we want to make sure that this is always less than, right? So we're looking at the worst case scenario. This is the worst case scenario. That's what we're really interested in when we're looking at this. What is the worst case scenario from you, x plus 5? Well, we pretty much know we're talking about getting pretty close to 5, right? Because we want to get pretty close to L. And so we're going to go ahead and say this x plus minus 5, or the distance between x and 5, is going to be probably less than 1. And so if the distance between x and 5 is less than 1, well, then x is going to be between 4 and 6. That makes the worst case scenario x equals 6 in the worst case, because that would make this the largest quantity it could be. That's where I got this 11. I know. It seems really weird. Okay? And so now I'm going to make the statement that my delta is going to be epsilon over 11. Okay? And so now let's write the proof. So first thing you always do with the proof, it's the same thing. You're always going to let epsilon greater than 0 be given and assume 0 is less than x minus 5 less than delta, where delta equals epsilon over 11. Okay, you're always going to write in the same way. You're going to make sure you put in your a value here, right? And then this is the delta that we chose from step 1. And now we just need to show and include, or what we want at the end is we want to show that f of x minus L is less than epsilon. Okay, so we're going to start with our f of x minus L. And what does that equal? Well, in this situation, it equals x squared minus 25 equals x minus 5 x plus 5 Where do we go from here? Right? What do we want to show? What am I looking to show? What do we want it to say at the very end? The very end, we want it to stay. We want epsilon over here. Right? At the very end, we want this to be an epsilon. And so what do we know? We know that x minus 5, what do we know about this x minus 5? We know it's always less than delta, right? And so I know that this then is always less than epsilon over 11 times x plus 5. Right? I know, what do I have these? I'm going to go ahead and drop these. We don't really need these at this point. All right, and what do I know about x plus 5? I know that at worst case, x plus 5 is 11. So this is always going to be less than epsilon. So my final statement is I have this f of x minus L less than epsilon. Okay, so one more time, what did we do here? Right, first we found our delta. And if we look at our definition, where's my definition? Do I have a definition somewhere around here? Here. If I look at my definition, for any number epsilon greater than 0, there's a corresponding number delta greater than 0 such that f of x minus L is less than epsilon whenever x is within delta of a, right? That's my definition. So first, we found a delta. We chose delta epsilon over 11, right? And then down here, we have to make sure that we make all the statements or take care of all the things in the definition. So we have our epsilon greater than 0 be given. We assume that x is within delta of 5. We chose a delta greater than 0, right? If epsilon is greater than 0, surely this is true. And then we write f of x minus L equals x squared minus 25. We just substitute in our f of x, substitute in our L. We get to x minus 5, x plus 5, right? I know that I want to show that this f of x minus L is less than epsilon. So I need to figure out a way to substitute in this epsilon here, right? And so how do I do that? Well, what do I know about this x minus 5 here? I know that the absolute value of x minus 5 is, first of all, I know it's positive, right? So I know that this positive x minus 5 is less than epsilon over 11. So I went ahead and substituted that in, and then with the knowledge we have, we know we can go ahead and drop these absolute value signs. This is going to be a positive quantity, right? We don't need to worry about that. So I dropped my absolute value signs, and so I have epsilon over 11 times x plus 5. Worst case scenario for x plus 5 is 11. Right? And so I go ahead and plug that in, and I get f of x minus L is less than epsilon. Therefore, the limit is x goes to 5 of x squared equals 25. Oh, therefore.